This Ada mini lecture is dealing with how to create pointers in Ada. So from what we've seen so far, let's go through and create just a basic record. So I'll say type employee is record, and an employee will have a name, and they'll have an ID number, and they'll have, let's just say, salary. That's our basic employee record, and we can go through and create a particular employee, and then we can manipulate the employee's name, and set their ID number and their salary. So Bob's living the dream. Let's make sure this compiles. Hit spacebar too much. And it is expecting a floating point, so it doesn't automatically compile for us. So here we have our basic record. Now, if we were wanting to handle multiple employees, we just create an array. I'd say type, say eArray for employee array is an array from say 1 to 100 of employee, and then I could create an array of them through workers. So here we've got our basic way of storing multiple employees. Now the problem with this is we may not have 100 employees by default, or if we are working with a major software system that's managing millions of employees for hundreds of companies, then this may not be the best approach. And although comparison and equality in Ada has many nice features, it also has several downsides. For example, if I were to say workers of 1 equals workers of 2, this would copy the data from workers 2 to workers 1. So we'd have a duplicate employee in this case. Now, this doesn't make sense with employees, but there are certain types of data where we would only want to refer to it instead of making a copy of it. And by default, Ada doesn't allow us to do this, so it introduces considerable overhead in the implementation of this. Because if we think back to two basic sorting algorithms, say selection sort and bubble sort, they're both n-squared algorithms, but if they both work on the same data set, selection sort is a little over 2 times faster than selection sort because it doesn't require memory access and copying at the level that bubble sort does. So not being able to copy memory can be a very, very good thing. And because of that, we need this capability in Ada, because we may not always want to use arrays to store multiple pieces of information for, say, an employee. Now, one thing that we can use is called a pointer. So instead of creating an actual employee and just having that work, well, let's create another type that can access an employee. So this is how pointers are created in Ada. So then I would say pointer P of type ePointer. Then I can set P equals to a new employee. And I can set the employee's name, so on and so forth. Sure that compiles. So essentially this allows us to access one of these records. Now in this case I'm creating that particular record at runtime, not at compile time, so for this to work. So this shows that it's dynamic. Now if I wanted to access a particular employee, then you would think you could just say, well, I'm going to have my pointer point to the particular employee. However, if we do this, it's not working because although this is a pointer, it can't be set equal to this. We have to access the memory location behind it. And one of the issues with pointers is there are multiple, or can be multiple pointers to the same piece of information, which means that they are aliased. And if something is aliased, then you can run into the typical problem where you have two pointers to something. You delete one of the pointers, in other words, you delete the memory behind it, and because of that, the other pointer is now pointing to something that shouldn't exist. So you've got what's called a dangling pointer. And in Ada, we have to go through and essentially say that this employee is aliased. I believe that's the syntax for that. Or not. One second. So result must be general access type. So what this is complaining is that the pointer can't just access it, it has to be access everything in this. So we have to have our variable say that it can be aliased. In other words, we know that this variable has pointers pointing to it, therefore whenever we're debugging it gives us a little bit of a clue to keep track of and make sure that the double deletion problem doesn't happen. So this is how we can have a pointer access a piece of information that's already there. Now in this case I'm going to set P equals to a new employee, and that works as well. Because once I've done this assignment, P is no longer pointing at the particular employee here, but it's accessing something new. And if I do this, well, P is going to point to a new employee, and P is going to point to another new employee, leaving this particular employee to be pointing to, well, let me rephrase that. The employee created here is not going to be pointed to by anything. It's essentially lost and is called garbage. And because of that, we have to come up with a method to dispose of this particular piece of information. So the first thing we have to do is we have to do a with ada.unchecked underscore deallocation. And then up here we have to say procedure dispose is a new ada.unchecked deallocation, and the particular object that we are working on is an employee, and the particular pointer that we are working with is called ePointer. So this is an example of a generic procedure that we talked about in a previous lecture, and what this allows is once we're finished, I can go through and call dispose on P so that the memory is returned to the system. Okay, got an extra S there. So that's how we go through and create a basic type, a pointer to that specific type, have access to that particular type through a pointer, and how to create the dispose method or procedure that can take one of these pointers and return memory back to the system so that if we create multiple ones, we don't have to worry about it. So pointers are a nice type that allow us to get around deep copying all the time and allow for shallow copying, because this doesn't copy the information from E into P, it just allows P to refer to or point to the information that this particular record has. Now, this record can be made statically, or it can be made dynamically at runtime. It all depends. Now, one of the nice things about Ada is the fact that at runtime I can create as many of these pointers as I want and keep track of them. So pointers allow us to move beyond the typical data structure of an array. And we can use pointers to refer to specific nodes, say in a data structure like a linked list. So if I wanted to have employee act like a linked list, well, I could add in a particular type here that would allow me to refer to another data structure. Now, I'm not going to do this because this isn't a package, but that's just one example on how this could be used to make a particular data structure. And we'll see an example of making a linked list in the next lecture. So this is the basics for pointers in Ada, and looking at how you can create a type, point to that particular type, refer to it with existing variables if you need to, and be able to remove the variables themselves from memory after you have created them.